Okay, so here is the device for lesson 121's assignment, creating a standalone device that unlocks with the RFID. Buttons move the server, and it saves the server position so that each badge, it'll return to the previous position when that badge had been scanned. So I deleted the file that I had been using to test it, so this will start fresh as if it's a brand new program. I'm going to turn the bread vault on. The servo will go through a test cycle. It's locked. Going to unlock it with light turns green. Now I'll move the server. You see the server is moving. Goes up. It goes down. I'll let it lock. You'll see when I press the buttons, when it's locked, nothing happens. Now I will unlock the servo with the card. And you see it goes back to 0. I'll move it back, move it all the way over to the other side, and then I'll let it lock again. I'll come back and unlock it with the first one. You can see the servo return to the position where it was the first time. I'll let it lock again. And now I'll do it with the card, and you see the servo return to where it was. See it clearly. I can keep clicking the button here, and then the next button decrements it so it's not overrunning the server. I think it's working as requested. So this is the code for lesson 121's assignment, creating a servo controller that unlocks with an RFID tag, moves by buttons, an increment and a decrement button, and then relocks after 5 seconds, and depending on whatever tag is used to open it, the servo will return to the last position that tag had moved the servo to. So import all the libraries. Most of them are we've used quite often. The servo SM is the library I made to use the state machine to move the server. Import the timer because I am using a timer instead of the method you used in the last episode. Again, I had to import MicroPython for that, my MicroPython schedule, and UJSON so that I can save the data. Set up the RFID reader, set up the servo through the servo library, give it a little bit of time to initialize, set up the LEDs, set up a lock timer and an unlock time variable so that if I ever wanted to change the amount of time before it locked, I can just change that variable. I put the servo through go to 180 and back to 0 just to initialize it, and then it also helps show that the servo will move again if it moves on startup. Here's the state machine button monitoring program. I have two. The servo is on state machine 0. The up button will be on state machine 1, and the down button will be on state machine 2. And here are the two interrupt handlers for the up and down buttons. I'll come back to those. And here's the system lock variable, or the function. It's very similar to the function from the last assignment. The only difference here is I did a try and accept to open the data, the JSON file where the data will be saved. Sorry, my dogs are in the background wrestling over a bone. Where the data will be saved, and then get the badge ID, and if the badge ID is in the file, it'll set the servo angle to whatever the data in the JSON file corresponds to that badge ID. And if there is no file, then it'll just pass, or if for some reason that badge ID hadn't been in the file, it will pass. Now and then it will move the my servo to the servo angle, which if there isn't a file, or that badge hadn't been used before, that servo angle would be 0, which is set here. Initialize the lock timer, which is the 5,000 milliseconds. Turn the green LED on. I forgot to mention the red LED came on here before the reader was, while the reader was locked. Print that the system was unlocked with the badge ID. Take the state machines and clear any leftover IRQ calls that might have been stuck in there, and then connect those state machines to their IRQ handlers. As in last time, I had the IRQ handler set to none when you enter this system lock, so that the buttons don't work or there isn't an IRQ. And then call this system lock through the MicroPython.schedule function here. This is just to keep the program alive, and then here's a keyboard interrupt to cleanly exit the program. And notice this has to be unlocked for this to work. When it's in the lock state, nothing else works. There might be a better way to do that where the keyboard interrupt would work even when it's locked, but I haven't figured that out yet. Pretty straightforward, not too different than the last one, but definitely works as requested.